Hi everybody, welcome to our first video. This lesson is lesson 1.1, so we're talking about functions, and today we're going to talk about some really basic thing about functions. So at the top here is where I have what lesson number it is. Over here will be what unit we're in. And then on this side I have some space, and that space is for you to write some things down. You can write down questions, you can write down comments. Sometimes I write things down over here that are just like scratch work in a way. So that's what that space over here is for. Let's go ahead and get started. You can read through the definition of a relation. A relation is just a relationship between two sets. That's all it is. But what we are going to focus on in this unit is a function. What's a function? And so a function is sort of a subset of relations. And there are some specific things that a function has. For one, there's only one output for every input. That is, every x has only one y. I'm going to write that down. All right, every x has only one y. The other thing that we know about functions is it passes the vertical line test, and that might be something that you have learned before is the vertical line test. And so when we talk about functions, we talk about things like domain and range. When we talk about functions, we use x, of course, and then f of x is another basic way of saying y. It's very similar to y. It's just a little bit more helpful. So x is always our domain, and y, or f of x, is always our range. Then we can also say that x is the input and y is the output, or f of x is the output. And if we think in terms of applications like science and things like that, we could say that x is our independent variable and y, or f of x, is our dependent variable. Now, I will also say about taking notes on video. Anytime I write something down, you should write it down too. And so if that means you have to pause the video, if I'm going too fast, just pause it and rewind it and we can go through it. Okay, some examples. Whether each of these is a function or not. We look for those two things on the definition. Every x has only one y, or does it pass the vertical line test? Quite honestly, the vertical line test is the easiest thing, I think, when we look at graphs. So do you remember the vertical line test? If I have a vertical line and I move it along my graph, then it should only cross one place anywhere I go. And so this is a function because it only passes once anywhere I go. However, over here, this example is not a function. Why not? Because like the place where I landed it right there, you can see it's hitting it twice there and there. So that is not a function. So this is a function, this one's not a function. And then we'll talk about domain and range. But before we talk about domain and range, let's go back and talk about these. So does every x have only one y? 0 goes to 4, 1 goes to 5, 2 goes to 6, 3 also goes to 6. So this is where we want to focus our attention and really think about it. But this is still a function because every x has only one y. However, on this one, the 1, it could go to 0 or 1. The 2 can go to 2 or 3. So this one is not a function because every x does not have its own y. This x has two different y's that go with it, so that makes it not a function. When we talk about domain and range, when it is a table, we can just list it out. So I'm going to use D to stand for domain, and I'm going to use kind of these braces that look like that. That was kind of messy, but that's what I'm doing right there. Here, my domain, I always start at the lowest. The lowest is 0, 0, 1, 2, 3. And the range, similar, but we only have to say 6 one time, okay? So when we talk about this, our range is 4, 5, and 6. The one that's not a function, let's not even deal with that for as far as domain and range. Okay, let's talk about domain and range here. The arrow means it goes forever, right? The domain is our x values. That means right to left. How far is it going right to left? So again, I said before, we start at the lowest. So all the way to the left, how far does it go to the left? Well, it actually goes all the way to infinity. We should call it negative infinity. And it's going to go all the way over here to positive infinity. So that says negative infinity to positive infinity. The range, again, the arrow again says negative infinity to positive infinity. And then this one, I know I said not to do the domain and range, but this is a good example. This one, left to right is our domain, and this one starts at 0. And then it goes all the way up to infinity. And the range actually does go negative infinity all the way up to positive infinity. We are going to talk about how to express the domain and range more specifically, but right now I'm just using those phrases, this to this. Okay, we can also express functions in 3 different ways, at least 3 different ways, as an equation, as a table, and as a graph. And each of these is a different way to represent a function. So, but they all should go together. So for instance, we should know how to plug numbers in. And if we plug in a -2, for instance, then we're going to plug it in like this, and we're going to work it out. And that's -4 plus 3, that's -1. If I plug in the -1, then I can do it mentally. I get a -2 plus 3, that's 1. I plug in a 0. 0 plus 3 is 3. Plug in a 1, that's 5. I plug in a 2, that's 4 plus 3 is 7. So there's my table, there's my equation, and my graph. This graph, I can graph a couple different ways. I can graph it from the table, or I can graph it from the equation. From the equation, I think it's easier. I know that I start at 3, and I go up to right 1, up to right 1, up to right 1, and then go down to left 1, down to left 1, down to left 1, and that will get me in the same spot. Did I do that right? 1, 2, there we go. It's a little off right there. That should go there. And then I can connect those with a line, and I'm going to do that here with a straight edge. So here's my line. I could have done it by a table. -2, -1, that's the one that I couldn't get quite right there. -1, 1 is right there. 0, 3, 1, 5, 2, 7. All of those go together. They're just different ways of talking about a function. Now, a function, when I first graphed it, I graphed it as a continuous function. A continuous function means there are no breaks in it, that it continues all the way. A discrete that's hard to say. Discrete function has breaks in it. And so it could be that it is just dots only and you don't connect them. It could be, we have a lot of different graphs that might be discrete. So maybe, for instance, kind of a simple one might be something like this. Okay, this has a break in it. This is my graph. This has a break in it right here and it doesn't touch. That means it is discrete. All right, let's turn the page. When we talk about function notation, typically what we use is an f of x. And so instead of saying y equals 5x, we could just say f of x is equal to 5x. F of x and y are really the same thing. They're just 2 ways of saying the same thing. So f of x is another way of saying y, but it has more functionality. What do I mean by functionality? Well, by functionality, I mean we can plug stuff in. So we did this a minute ago, but we could plug in here. We could take this -1, and we could plug it in here, and we would get 5 times -1, and that would be -5. So that's what we can do with function notation. We can plug in certain numbers. So that was plugging into an equation, but remember, we can also look at things on a graph. Now this function is totally different from this one. These are 2 different functions. But -4, if I plug in a -4, by the graph, I'm going to get 8. So this time, f of -4 is 8 because that's where it is on the graph. So we need to know how to look for it on the graph, and we need to know how to plug it into the equation. We could also express this as a coordinate or even as a table. So for instance, if this was a table, then my x would be my -4 and my y would be my 8 because my x was my input, my y is my output, or my x is my over here and my y is up here. Or we could even express it as a coordinate, as a -4, 8. All 3 of these things all mean the same thing. These 3 all mean the same thing. Okay, remember I said we were going to talk about notation? We're going to talk about that next. All right, if we take a look at this one, here we have a line. And we should remember from our elementary or middle school experience how to write the inequality that matches with this line. And so it is pointing to the right, and m is the variable. So we could say m is greater than -6. And now the question comes, oh, wait a second, is that supposed to be greater or greater than equal to? So we need to go back and remember. So remember that if it is a solid dot, that actually has an equal to with it, whereas if it has an open dot, then there is no equal to. You should write this down because we're going to expand on this. So this really, I had written greater than, I should say greater than or equal to. M is greater than or equal to negative 6. The other one, the N, that's the one down here. I'm going to call it N is less than 2. So we start at the 2, we go to the left, that's everything less than, and it just goes forever. It is an open dot. Open dot means you do not have equal signs. Okay, now we're going to change this over to interval notation. There are a couple things you need to know about interval notation. One thing is, and this is probably the most important thing, is that when you have these equal signs or solid dot, the interval notation means we're going to use these brackets. However, if we don't have parentheses, or excuse me, we don't have solid and we don't have equal to, that means it does not include it. And when it does not include it, then we use regular old parentheses. So this is information that is really important for you to know. Because what this is going to tell us for this is when we look at intervals, we want to go all the way to the left, all the way to the right. And we always start at the lowest point. So with M, that was our top line, our lowest point is negative 6. And how far does it go? Well, it's going to go all the way to infinity. So from negative 6 to infinity, we put a comma in between it because we're lazy. Like we don't write the word two letters, it's so long. We just put a comma. And then we look at our rule over here, and it was a solid dot. Solid dot means it does touch it, and if it does touch it, then we put a square bracket around it. Now infinity, we never quite get there. We never quite get to infinity, so we're going to put a parenthesis on that side. Let's take a look at the other one. How far does it go? We always start at the lowest point. Well, the lowest point over here is an arrow that's going to go to negative infinity. So that's one part of it. And how high does it go? Well, it goes up to 2, and then it stops. And so again, we just put a comma there. Now, it stops. Does it include the 2? No, it does not include the 2. And if it does not include it, then we use these parentheses. It also does not include the negative infinity, so parenthesis there. All right, we're going to try a couple of examples. This is kind of hard to see on the screen, so hopefully you can read on your paper. Okay, and so because it's so hard to read on the screen, I went ahead and told you where these are. This one's at negative 7.3, this one's at 5.1. So when we talk about domain, we go from left to right. We start at the smallest and we go to the biggest. The smallest is down here at negative 7, and then it goes all the way over to the right, all the way to 5. That's what that comma means, just from here to here. All right, solid dot means it has the bracket. Open dot means it has a parenthesis. Let's take a look at the range. The range is top to bottom, or actually bottom to top. We start at the lowest. We start at the bottom point and go up to the top. What's the lowest it goes? It goes to negative 3. I had a misprint here. We should put a negative on that because it is negative 3. And it goes all the way up to 1, but then it stops there. The negative 3 has a square bracket. The 1 has a parenthesis. Okay, on number 2, I actually like number 2. I'm going to zoom in a bit. What I like about number 2 is you have to think about it. So number 2, that is the point 0, 0 right there. And it does touch 0, 0. If there's not a big fat dot on it, it still touches. We just use those to kind of emphasize one way or the other, but if there's not one there, it means it still does touch. So our domain is left to right. Starting on the left, it goes all the way down to 0 on the left. How far is it going to go to the right? It has an arrow. It's going to go to for infinity. And infinity always gets a parenthesis. This time the 0, even though there's not a big fat dot on it, it still gets a square bracket because there is a point there. It does go to there. It does touch there. The range, top to bottom, or actually bottom to top. So bottom to top. How low does it go? 0 is as low as it ever goes. How high does it go? It's going to keep going all the way up to infinity on the y-axis. Never gets there, though. You can't get to infinity. And the range on this one, it does touch it, so we are going to enclose that with a square bracket. Okay, last one's kind of funky. I want to talk about a couple things. First of all, it is not continuous. You want to write that down. That is not continuous. Remember I said before, continuous means that they touch the whole time. This has a break in it, so it is not continuous. However, The domain and the range, if we just look at the domain and the range, they actually appear to be continuous. And we'll talk about this. So the domain is left to right. How far does it go on the left? It goes all the way to negative infinity. And then it goes all the way over here up until the 1, and it stops. And there's a hole, like it does not exist there. However, it does exist here. And those overlap each other. And so the domain actually does keep going. How far does it go to the right? It goes to infinity, because that's what that arrow means. It's going to go to the right. The range, start at the bottom. How far down does it go? Well, it goes all the way to negative infinity down here. And then we go up, 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 as high as we can go, and it stops at 4. 4 has a solid dot. We're going to put a square, and infinity always gets a parenthesis. Okay, one more thing about taking notes in this class. Oftentimes I'll have these summary lines down here. You need to write something in there. That is for you when you want to go back and remember what is important. The important stuff is written down here. So as you flip through these 2 pages, what was the important stuff? To me, I think one of the most important things is this little diagram right here. And so you might want to reproduce that down here. Anything else that you think is important, you would want to put in here. Another thing about taking notes, sometimes people get really frustrated. The one thing that people don't like about taking notes on video, I always hear this, is I want to ask a question. I want to ask a person. And it's true. You can't ask a person during the video. I mean, you don't, I'm not there. You can't see me. However, any questions that you have at any time, you write them in the margin. In fact, you should almost always have a question, at least one, that you're either asking yourself or wondering about or whatever. Write down a question in the margin. That way, when you come to class the next time and I say, okay, who has questions on the video, you can tell me what question you wrote down. So I tell you what, even though maybe you don't have a question, think of a fake question and write at least one question somewhere on here. Write down a question. Maybe you don't know what a relation is. Maybe you don't know what a function is. Whatever. Write something down in the margin so that you have a question somewhere in the margin. The margin questions and the summary at the bottom are going to be the things that are most helpful when you look at your notes next time. Okay, make sure you write those down. Bring your questions to class. We're going to talk about this when we see each other again.